Hello and welcome everyone. So I'll be explaining recent DIV3 round 702 problem A and problem B. So let's jump into the problem A first. The problem A, dense array. So in this problem, you have to tell whether this array is dense. To make whether this array is dense or not. If it is not dense, then what is the minimum number of elements that you're going to be inserting inside that array to make that array dense? Now, before jumping into the operation, we need to know what does it mean by the dense array. They have clearly told us that dense array means for any two adjacent values, of an array, if I do a condition like this, if the maximum out of these two adjacent values divided by the minimum out of these two adjacent values is less than or equal to 2, then I'm telling for each and every I, okay? For each and every I, this has to be fulfilled, which is maximum divided by minimum, and maximum and divided by minimum of the adjacent values, okay, from the adjacent values is less than or equal to 2. So if that condition fulfills for each and every I, then this array is called dense. Now, the array that you're going to be given, for some index, it might not contain that. So to make that dense happen, you have an option. What is that? That option is that you have to insert some numbers. You can insert any number you want inside any of those, between any of those two values. You can add any values you want. And finally, you have to answer what is the minimum number of insert operation you have to make the array dense. Okay, to make the array this as possible. Okay, so what should be the approach here? What I actually thought that, look, I have to find out what the minimum number of numbers, okay, minimum of numbers that must be inserted. So what the idea that came to my mind was, okay, look, now let's take one example here. 4, 2, 10, 1. Okay, this example looks pretty dope. 4, 2, 10, 1. Okay, now look, in this array, if I do check for this positions dense, then it is applicable, because 4 by 2 is 2, which is less than or equal to 2. But for this part, 10 by 2 is 5, it's greater than 2. So that does mean that I have to insert some values. Definitely I have to insert some values inside this, no matter what happens. But I have to insert such that it becomes a minimum. Now, how can I make it as minimum? What is the right approach to make it as minimum? If I closely look at the constraints that were given inside the condition, they have told us that maximum divided by minimum will be less than or equal to 2. Now, what does that indicate is maximum divided by minimum is less than or equal to 2 means maximum less than or equal to 2 times minimum. Okay, so if I just manipulate this condition, I can come to a conclusion that, okay, what is the highest value that I can achieve from the minimum? What is the highest value that I can go for from the minimum? it is multiplying it by 2. Not 1, not 0, not between any number, but multiplying by 2. So that's the thing that we have to do. This is the optimal approach, because the farther that farther I can go, maintaining my constraint and condition is actually multiplying the minimum by 2. So what I have to do is one value. The first value that I can insert inside it is 2 times 2, 4. Okay, so I have inserted 4. Then what? If I check once again 10 by 4, okay, if I check once again 10 by 4, it's actually 2 point something, right? 2 point something, which is also greater than 2, which means this does not fulfill also. What I have to do, I will multiply it by 2. Also multiply it by 2. The farther I can go, maintain. But the farther I can go from this position, from the minimum position, which is the temporary minimum actually, because that minimum is going to be multiplying it by 2, where we're going to be running out from that. Now for this value, we're going to be multiplying it by 2. Why? Again, why I'm multiplying it by 2? I'm multiplying it by 2 because I have to go farther. But also I have to maintain my general condition that I have to fulfill. That is the only thing that I can do by multiplying it by 2. From what? From starting from the minimum value, right? Starting from the minimum value until I reach a point where this condition offers something like this, less than or equal to 2. If it does happen at some point less than or equal to 2, then yes, okay, so I have reached a point that I don't have to add anything. Again, you could do that any other way, but that is the most optimal, because I'm going farthest possible, maintaining my condition here. I hope I made you understand. So for this value, for this example, which is 4 2, what was that? 4 2 4 2, let's take it 4 2 10 1. So the values will be inserted is 4, and then 4 times 2, 8. And then this, for this one, okay, 1, there's 1, okay, 1 times 2 is 2, 2 times 2 is 4, 4 times 2, and 4 times 2 is 8. So how many values that I have inserted? 1, 2, 3, 4, 5. As you can see, the answer is 5. So I have to, the minimum option is 5. So the minimum number of numbers that must be inserted is 5. Exactly like this, we'll do everything. Like let me take you to the code part. The code part is here. Taking t and then taking n, and then this is the array. Taking the array from the for loop and starting from the second index, because I'm actually trying to figure out from here by checking this, okay, and then coming here, also checking this, coming here, also checking this, so that I don't have to worry about the last index, and I don't have to give condition for the last index. That's why I'm actually starting from this, so that I can compare these two each time, these two, previous two, like this. Okay, and then what I did was, okay, maximum, this is my maximum, this is my minimum. Now this condition is actually checking whether it is fully a mod value. If it's equal 0, then the temp is not fraction. If it's not fraction, then the result will be accurate. If it's not, then I'm actually adding 1 just to maintain that, okay, because it's a fraction, it will always be greater, something greater, so that's why I'm just adding 1. It doesn't matter, you don't have to take the fraction here. Just exactly like this, and then this is the main part here, checking inside the while loop whether it is greater than 2. If it's greater than 2, then it's not dense yet. If I have to make it dense, okay, because this temp is always comparing from the maximum to the temporary minimum. What is the temporary minimum? Temporary minimum is going to be multiplying it by 2 and 2, checking out each time, multiplying by 2, This is my counter, how many new numbers I'm going to be adding, and this is for the new temporary value that's going to be available in the next iteration, and also checking each time whether this is greater than 2. If it's greater than 2, then I have not made it dense yet. If at some point if it becomes less than or equal to 2, then yes, I have successfully made this two positions, between the maximum and the minimum positions, a dense part. So for each and every two indexes like this, okay, I'm gonna be adding for each and every group, trying to make it as dense as possible, and making by allowing the minimum number of numbers inserting, I'm gonna be finding out the result. But that's how we're gonna be doing this, and so that's it. Finally printing the answer. Now let's go to problem B. Okay, balanced remainders. Okay, so in this problem, let me finish it. So balanced remainders. Okay, now the tricky part is that there's no tricky part actually. If you analyze it, it will say this statement here, right here. If n is divisible by 3, this is very important here. For this problem, this is very important statement. This is the key statement here. N is divisible by 3. Okay? So what you have to do is, let me explain it. You're going to be given an array. You can apply an operation, which is you can increase any element's value by 1. Any number of times, it doesn't matter. Okay? Now, there are three variables, C0, C1, and C2. What does they define? They define C0 means if any number of if an element is AI, and if you mod it with 3, if that mod value is equal to 0, then that number belongs to C0. If that mod number equals to 1, that number belongs to C1. If the mod value of AI mod 3, okay, if you do AI mod 3, and if it gives the result as equal to 2, that number belongs to group C2. Okay. Finally, you have to print what is the minimum number of moves you need to make this array balanced remainders. Balanced remainders indicating that at some point you have to measure C0 equal to C1 equal to C2. Okay. This number of members, okay, inside this array team, the members C0, C1, and C2, the number of these groups will have to be equal, and you are allowed to do an operation which is increase any value by 1, and you have to do that minimum number of moves. In one move, what you can do, you can increase any value by 1. That's it. That's basically it. So the key observation is, remember what I told you, n is divisible by 3, which is indicating that no matter what happens, the sum of these C0, C1, and C2 will always be divisible by 3. And if they are divisible by 3, then their divisibility number, which means C0, C1 plus C2 divided by 3, what is that number? That number is what you are going to be looking for, which means your task is basically goes down to, you have to measure something like this. I'm telling you, look, if I say temp equal to C0 plus C1 plus C2 divided by 3, then what you have to do eventually, what you have to do is you have to make C0 equal to temp. Only then C0 equal to, because I know I have a guarantee that they are going to be divisible by 3, and that's why if I have to do that in a minimum number of fashion, the temp is the optimal value. Temp is the optimal value to make it C0, C1, and C2 also make it as temp, because they're all same and they're all divisible by 3. So intuitively you should have that intuition that yes, this is the minimum possible possible location that I have to follow for this. So my target is to make C0 equal to temp, C1 equal to temp, and C2 equal to temp. That's it. Now, one thing also I have to tell you is that let's say I have C0, C1, and C2. Okay? Remember, when one move happens, let's say I'm making some move. Let's say I'm making some move, which is, okay, let's take one example. Let's take it. Let's say, let's say that I have, from that array, I have calculated what are the values of C0 and C1 and C2, which is 1, 1, 4. Okay, 1, 1, and 4. Okay. When I make one move, what happens actually? A transition happens. We know that 1, 0, 1, 2 belongs to C0, C1, and C2. Now if I go forward also, 3, 4, 5. Now 3 also belongs to C0, C1, and then C2. Okay? If I go also next, 6, 7, 8. This number also belongs to C0 group. This number also belongs to C1 and C2. Okay? So the general observation is this, because it's obvious, because you're doing modular operation. So they will always follow a cycle like this: C0, C1, C2, C0, C1, C2. Okay? They're in relation. So what actually means is if you increase, let's say you do a move, if you increase C2 by 1, let's say you have increased the C2 members, one value of C2 members. One value of C2 member, you have increased it by 1. When you increase it by 1, then the count of C2 decreases by 1 and the count of C0 increases by 1. Isn't that true? Of course it's true, because look, let's say I have one C2 what here from this arena, I say that 2. This is my C2. Now if I increase 2 by 1, what it becomes? It becomes 3, which means this belongs to C0, because 3 mod 3 is equal to 0, which means C0 increases and C2 decreases. That's exactly how it works. Okay, so what you have to do is similarly for C0 and C1, if you increase any number from C0 member, exactly what happens is the count of C0 decreases and the count of C1 increases. That's exactly what they're going. They're going in a cyclical order: C0, C1, C2, C0, C1, C2. That's how they're going. Because I'm doing a mod operation, that's intuitive. I hope you get that. Now, after following this observation, now you have a clear idea how things are going to work. What I actually did, simply just this. I will calculate what is the maximum value from these three values. What is the maximum? Is it C0, is it C1, or is it C2? Each of the cases can be maximum value. Maximum can be inside any of those C0 or C1 or C2. It can be. If it happens, okay, for that I'm taking another task, and for each of these three groups, if they become maximum, I'm doing their separate part. Let's assume that C2 is what? Now 4. Now C2 is maximum. What I'm going to be doing, decrease it by 1 and then increase it any of those values, any of those C0 or C1. But also I have to take one condition. I have to see whether any of this C0 or C1, is it becoming our target temp value? If it does not become our target temp value, then I can increase that number. Okay? Because if it becomes equal to my temp value, then I cannot increase that value. That's obvious. So that's exactly what you have to do. And remember, when you increase one number by 1, two values changes inside these three groups of team. Okay, so if I say that any number which belongs to C2, I'm increasing by 1, the values that are changing is C2 and also C0. But how many moves did I do? I just only did one move. But by doing one move, how many values did changed in my C0, C1 and C2? Two values changed because they are going cyclical order. C0, C1 and then C2 comes. C0, C1 and then C2 comes. That's exactly how they're going. I'll take you to the code part. Now look. I'm taking T, N, and this is my target. And remember what I told you, N by 3. Now taking the value, and then this is actually measuring how many C0s and C1s and C2s are there. I hope you get that here. This is the fun part. Inside the while loop, this is the initial condition I'm checking, whether C0 becomes C1 and C1 becomes equal to C2. Because this is actually indicating the temp, because if they all are equal, then definitely they all are temp. It will always be equal to temp if they are all equal. C0 equal to C1 and C1 equal to C2. Okay? But why did I need this target? Oh, sorry for that. Here temp means actually the mod value. I'm actually referring to the target. Look, this condition actually referring that I have reached my target value, because C0 equal to C1 equal to C2 means only one thing, that they are equal to target value, because n by 3. I did n by 3, and n is always divisible by 3. And taking out the maximum one, and checking out each condition. If maximum equal to C0, or if maximum equal to C1, or if maximum equal to C2. Let's assume that we're considering that maximum equal to C0. What we will do, we will, no matter what happens, if it is maximum, what we will do, we know that it's gonna be decreased by 1. I have to decrease the count of C0 by 1. By what? By increasing the some member value of C0 by 1. And when I do that, what changes? Value C1 changes, but how many operations did I do? Only one. I increased one value, and it impacts two values of the different groups of count, which is C0 and C1. And C1 or C2, okay, and C1 or C. Um, yeah, okay, sorry. Oh, sorry for that. Here, I have to explain you, okay. Okay, so this part here, what's going on here, I'll explain you right now. Let's say I want to do this. C0, C1, and then C2. Now 1, 1, 4. Now what actually happened here was, if I increase some numbers from here by 1. Okay, let's just focus on their number. If some number from C2 decreases by 1, so what it becomes? It becomes 3. If it becomes 3, then that number goes to what? C2. C2. Okay, C2. Then it becomes what? 2 and 1. Then I'm assuming that this is less than target. Okay, this is also less than target. Now remember, okay, this becomes 2, this becomes 1 yet. Now what I can do is, I can either increase this or increase this, it doesn't matter. If I want to increase this C1, okay, if I want to increase this C1, I have to do how many operations? 2 operations. How? I have to increase it by 1 and take it to the level of C0, and also then I have to increase it by 1 to take it to the level of C1. But does that change my minimum number of moves? No, it doesn't change, because sooner or later you will always do that. How? Let me explain to you. Look, 4 becomes 3 and then it becomes 2 to 1. Now what I can do is somehow I have to do something like this. C0, okay, from C0 this becomes 1 and this becomes 2. This is general observation. So what I'm trying to say you is that it doesn't matter which one you increase at first, but if they are adjacently connected, like C2 is adjacently connected to C0, so if I increase C2 some value by 1, it becomes C0. But if I want to make C0 some value equal to C1, I have to do 2 operations. But still, it does not affect my result. At some point, they will uh, give me my minimum number of moves, always. Okay? That's exactly what I'm trying to make you understand, and that's exactly what happened here. That's exactly why I increased res here, because for C0, its adjacent part is C1. So that's why I did this. But if any case happens at some moment, if I feel that no, C1's target value is fulfilled, I have to fulfill then C2's target value. What I have to do is C2 plus plus and then res plus plus. This res plus plus is what I am adding 2 more values. So adding 2 more values from C0 group's array. So that's exactly why I have to do this. And this same thing goes for the other cases. So I hope you understand that. I hope I made you understand that.